Bismillahirrahmanirrahim. This video aims to explain why we need a new approach to statistics. To learn more, register for the online course linked here, which aims to rebuild the discipline of statistics on new foundations. Let me start by listing the four flaws: assumptions, a positivist theory of knowledge, a wrong definition of probability, and no definition at all of causality.
So if you do statistics, you're familiar with the idea that, okay, here's some data, let's assume it's normal. Where do you get this? How can you assume it's normal? What happens if the data is not normal? Similarly, in regression analysis, you assume that errors are independent and that they have mean zero, and you assume that there's you assume exogeneity, which nobody really understands because there is no definition of causality. What it really means is that there is no causal relationship between the errors and the regressors. Now, what allows us to make such assumptions? The answer is nothing except computational convenience. You can get answers only if these assumptions are true, but there's no other justification for these assumptions. So one thing that we don't realize, I didn't realize when I was studying these, that everything that we say afterwards is actually driven by these arbitrary assumptions. I used to think, and most students believe, that what we are saying comes from the data, but it doesn't come from the data, it comes from the assumptions. And by changing these assumptions, you can get whatever result you want from whatever data set you have. So basically, the result that you want is coming from what you assume, and you can change the assumptions to get whatever result you want. Okay, so the second flaw is the positivist philosophy of knowledge. What does this mean? Well, basically, very roughly, we have been describing this whole process in detail. After the Europeans rejected Christianity and rejected God, they said we can't trust in the unseen, because God, angels, after that. So what we'll do is we'll restrict knowledge to what can be seen and touched. So here you have a picture of an iceberg. And the positivist philosophy of knowledge says that you can only look at the appearances. If something is hidden, then we cannot have knowledge about it, and we should not even try to get knowledge about this. So that's the positivist philosophy of knowledge. So what that means is that what is unobservable, you can't know. So only what is observed is the subtopic of knowledge. So if you observe something, then you can obviously measure it in many different ways. You can take the photograph and measure it, and many other ways. So that means that since we are only dealing with appearances, we're not dealing with underlying reality, you can always reduce everything to numbers. And then basically a statistical analysis starts with the data sets and ends with the data sets. You only talk about numbers. You never talk about the underlying reality. The third problem is wrong definitions of probability. Nearly all textbooks tell you that the probability is the limiting frequency of the proportion of heads in an infinite number of trials. This is completely wrong. It's actually meaningless. It's ridiculous. The reason that positivism prevents you from reaching the natural definition is that the natural definition has to do with unobservables. When you flip a coin and you say the probability of heads is half, what you're saying is that it could have come up tails also. But this it could have come up tails is not observable. So this natural definition is not available to positivists. There is another problem that is sort of related but not exactly the same, and that is determinism. Once you see the Europeans replaced religion with science, then they said, okay, Newton's laws are the basis of everything, and according to Newton's laws of physics, once the universe starts, every particle will follow a deterministic course to the end of time. So there is no freedom. If there's no freedom, then there's no chance, there's no real probability. So you can't define probability. So something else could not have happened, because there's only one thing that can happen, and that is already determined. And the fourth problem is that there is no definition of causality available. So here is basically the data cannot differentiate between correlation and causation, because data can only show correlation. See, if you think of the positivist philosophy, the appearances of causation are only in correlation. You can't really see. Causation is a hidden, deep, underlying concept. It cannot be observed except through correlations. So, for example, there's a very strong correlation between ice cream sales and shark attacks. But of course, these two things have nothing to do with each other. But that's the only thing you can observe. So the point is that actually when you have a sunny day on the beach, then you have lots of ice cream sales, and also you have lots of people, so you have the increased probability of shark attacks. But this thing we can understand only because we know about the real world. We know about summer, we know about beaches, we know about sharks. Without this underlying knowledge, if you just had two sequences of numbers which are highly correlated, there's just nothing you can do. No kind of data analysis which will tell you the difference between this data set and some other data set where there is general correlation. So basically you have to go underneath the numbers to the real world if you want to learn about causation. So what are the contributions of this textbook or course? We will handle all of four of these problems. So we have the realist philosophy of knowledge. Now the realist, unlike the positivists who say that knowledge is only of appearances, the realist philosophy says that real knowledge is only of the unobservables, exactly what is ruled out by positivism. So what about the appearances, what we can see? What we can see is only a clue to the unseen. So we have to use the clues to discover what is the hidden reality. But knowledge is only of hidden reality. It is not really about appearances at all. So this means that data analysis can never end with numbers. Ultimately, when we do a data analysis, we must come to a conclusion about the real world. And the data is never enough. It never provides sufficient information. You have to go beyond the data to the real world context. So these things are all very different from the standard approach. So one of the implications of this real statistics is that there is no universally applicable methods of data analysis, because each data analysis is specific to the real world context. So every real world situation, exactly the same set of data, same set of numbers will be analyzed differently if it is coming from Australia, and if it is coming from China, if it is coming from Africa. The data analysis will not be the same, because we will shift it according to the real world context. So what that means is that real statistics is difficult to learn, because there's no one pattern that you have, no one technique that will apply everywhere. So there's only one method, which is the apprentice method, case by case. We take a data set and we take a real world situation and we study it, and then you learn something. And then you take another real world situation, and after you do a lot of these studies, you begin to get some understanding of how data analysis should be done. So we will also introduce a new theory of probability. And this is time branching dependent probability. So I'm just giving you an example. Suppose that the Spanish Armada sets sail for England, and the next day there is a weather event. Either it might be calm, in which case the ships sail through to the England and the Spanish army sinks the British Navy, or there is a storm, and then the Spanish Armada sinks. And that's what happens on the third day or the second day. And if you're on the first branch where the Spaniards win, then basically Spain gets to rule the world because England has been destroyed. But on the second branch, Britain gets to rule the world because Spain, which was its rival, gets destroyed. So this is so the probability. There's only one probability event here, and that is the weather event. Whether there will be a storm or whether it will be calm. So the point is that probability must vary with time. When you say what is the probability of a storm, you have to ask at what time. Is it before the storm, which is at t equals 0? So at that time, maybe the probability is 40%. But after the storm, it's either 100% or 0%. Either the storm happened or it didn't. So on day 2, you cannot ask about the probability of the storm because the event has already taken place. So probability exists before the event and is extinguished after the events. And to evaluate the probability, we must know the time at which you are evaluating the probability. So this is something which is not mentioned in any of the standard theories of probability. So there is a famous theorem called the Bayes rule, and if you look at any textbook, it will mention that there is a Bayes rule, and it's a simple, trivial mathematical truth that the probability of A given B is equal to the probability of B given A times the probability of A. So actually this thing is false. This is true only if the two events are taking place at exactly the same time, in which case you can reverse A and B. But if the events are sequential in time, then you can talk about the probability of future given the past. That is permissible, but you can't talk about the probability of a storm today given that Spain won the battle tomorrow. That just doesn't make any sense because what happens today will determine what happens tomorrow. So you can't condition backwards. So if probability of A given B is defined, then probability of B given A is not defined if the events are chronological. But this very simple intuitive fact is not mentioned in any single textbook of probability. And finally, we have that there is no definition of causality in current textbooks, none at all. Now, it's very interesting that infants can learn about causal relationships. Almost from birth, they understand that if I suck on the mother's breast, I will get milk. They understand that if I cry, somebody will come to help me. And they understand that if they try to grasp an object, they can pull it closer to them. But the philosophers cannot understand. For centuries, ever since David Hume pointed it out that you can only see correlation, you can't see causation, they have been trying to figure out what causation means without success. The number of books and articles on causality is so huge that you can't even read all of them in a lifetime. So what is it that infants find easy to understand but philosophers don't? That's because philosophers are committed to this deterministic world. If you have a deterministic world, then everything was determined when the universe was born. After that, there is no free choice. In that case, there is no cause, because everything that happens was already caused from the t equals 0. So the initial conditions determine everything will happen, and basically everything altogether determines in the past, determines everything together in the future, and there is no individual cause that I will pick something and that my choice will make a difference. So to make it simpler, suppose we say that I take this billiard ball and I hit it with a stick and it moves. Did my hit cause the ball to move? Well, in a deterministic universe, there was no other possibility. I must hit the ball and it must move. But the real meaning of causality is that if I had not hit the ball, it would not have moved. This is what's called a counterfactual. So the counterfactual could not have happened, and in positivist philosophy, even if it's possible for it to happen, we can never know about what did not happen. So in either case, there is no possibility of determining causality. Now the thing is that the babies understand that I can choose to do something and I can choose not to do it. I can cry and call the mother, or I can refuse to cry and not call the mother. Or if I touch this ball and hit it, it will move. If I don't touch, it will not move. So babies learn both sides, that what happens if I do and what happens if I do not do. And that is how they learn the counterfactual. They know that if I do nothing, the ball will stay there, but if I push it, it will move. So both sides of the counterfactual they learn from experience. So the babies can learn about counterfactuals, but philosophers are still arguing about it, and they have no understanding of what counterfactual knowledge is and how we can get it. So basically, I can summarize and finish by saying that there are two axioms which philosophers use in their study of knowledge. One philosophy is determinism, which means that everything just will happen. There's no two choices. Nothing can happen by chance. Everything that is going to happen is already predetermined to happen. So in that case, there can be no probability and no causality. And then there is this logical positivism, which says that even if there is freedom, even if there is choice, even if there is chance, we can never know what might have happened. So there is no possibility of knowledge about probability. So basically, that's why conventional probability is built on flawed foundations, and that's why we need to build a new theory. So I end with this quote by Bertrand Russell: probability is the most important concept in modern science, especially because nobody has the slightest idea of what it means. And this is exactly true. Nobody really knows what probability means, because once you adopt the positivist framework, there's no way, it's impossible to understand probability.